Alright, just a reminder what an isotope is. Remember, an isotope is the same element but different mass number, and so therefore it has a different number of neutrons. So for example, if we have two fluorines, fluorine 39 and fluorine 40, fluorine 40, so fluorine 39 means it has a mass number of 39, and so if we were to figure out the number of protons, neutrons, and electrons for fluorine, looking at the periodic table, fluorine is 9, and so its neutrons will be 30, because 39 minus 30 is 39 minus 9 is 30, and then it's neutral, so it's 9 electrons. Fluorine here, 40, would be 9, because it's the same element, 31 neutrons, and 9 electrons. So what I want you to notice is it's still fluorine, but it has a different number of neutrons, and because it has a different number of neutrons, it has a different mass number. And so this is the example, or this is the idea of an isotope. An isotope is the same element, but just different types, different masses. On your periodic table, you'll notice that you have what's called average atomic mass. And so I'm going to first show you how to calculate it, and then we'll talk about what it means. And so it says calculate the atomic mass of copper. So this has to do with abundance. So in nature, the type of copper 63 isotope, there's about 69.17% abundance. And then copper 65, there's about 30.83% abundance. That just means that in nature there's more copper 63 than there's copper 65. And so what we're going to do is we're going to calculate the average mass, atomic mass. So what we do is we take the mass. So in this case, you have copper 63. So copper 63. And what we take is take the mass number, 63, and multiply it by the percentage. Now, if you remember in math, when you multiply it by a percentage, it's actually divided by 100, right? So this would be the 69.17% is 0.6917. And so that equals times 0.6197. Oops. So this equals 43.5771. And then copper 65 is 65, the mass number, times the percentage. So it's 65 times 0.3083. Now, with these two numbers, I just add them, so plus 20.0395. If I add those two, I get 63.61. We'll just round it to a 2. So this is the average atomic mass. And what it tells you is, as you notice, if you take a look, this this average atomic mass is closer to 63 than it is to 65, right? And so what it tells people is that the more common isotope, or the higher abundance, is copper 63, which we can confirm here. About 70% is copper 63. Okay? All right. If we take a look at it, so it says boron exists in two isotopes, boron 10 and boron 11. Based on the atomic mass, or the average atomic mass, which isotope would be more abundant? And so if you look at boron, boron is atomic number 5, it has an average atomic mass. So boron has an average atomic mass of 10.81. So I found this number was directly below the elemental symbol. And so you notice that 10.81 is closer to 11 than 10. And so therefore, boron 11 is more abundant. And so previous teachers might have told you you should take the average atomic mass and round it to the nearest whole number. And so the reason why is because if you round to the nearest whole number, what you're showing is you're predicting the most common isotope, and that's because it all has to do with this relative abundance. All right, go ahead and try number 3 on your own, and then press pause, and then I'll do the math with you after you're done. So lithium-6 is 4% abundant, so if I want to do lithium-6, that'd be 6 times 0.04, and then lithium-7 is 7, the mass number, times 0.96, so 6 times 0.04, 0.24, and then 7 times 0.96, 6.72. You add those, 0.24 plus 6.72. Equals 6.96. So the average mass of lithium is 6.96. All right.